So generally in Python there are two kinds of loops. There are while loops and there are for loops. For loops are for things with definite conditions. You're stepping through a sequence. You're stepping through a range of values, right? For x in range, whatever. While loops are for more indefinite conditions. You're just going to keep repeating something, some kind of condition, until the condition becomes false. And the program doesn't really know in advance how many times it's going to take to repeat before it comes false. Now you can write a while loop that does the same thing as a for loop, pretty much. Right? If you wanted to count from 1 to 10, that's a definite loop. So you would just use for x in range 1 parentheses 11, and it would go from 1 to 10. But you could write a while loop that did that too, right? You'd just say while x is less than 11, right? Or while x less than equal to 10. And as long as you remember to do x plus equals 1 in it, right, like that, then it would also serve the purposes of a definite loop. That's okay. In general, you're going to want to use for definite loops if you can. And you're going to definitely use while for indefinite loops. So this gives you one way out of the while loop, right? It's like you're doing your morning jog, and they're not going to let you off the trail until you've run past them 11 times. Well, 10 times, right? The time when it finally hits 11 is when it's going to let you out. You know, honestly, when I'm doing it with a while loop, despite the fact that with the range you put 1 past the place where you're stopping, I really like to do less than or equal to there. Yeah, come on. So there you go, right? You start running down the trail, you make a lap, the gatekeeper asks you, are you done? Is x still less than 10, less than or equal to 10? Yeah, so it runs through again, it runs through it again, it runs through it again. There's only one way out of the loop. But what if for some crazy reason you did this? That's a break statement in there. What it's telling is that no matter where you are in the loop, even if you haven't done a complete lap or whatever, just exit that loop right then and there, right? Throw you all the way out. So when x started at 1, it did something, it added 1 to x, it kept doing that, but then finally when it gets here and it does that check, and this is true, when x is equal to 6, it breaks. It exits the loop, so it exited early. It didn't get all the way up to 10 or 11, whatever the upper bounds is going to be. It bailed out of it early. And a lot of textbooks don't even really show making good use of the break statement, and this one does, for which I am proud of. So for example, we could write a sentinel loop where we ask them for a number, and then when they type in -1 instead, we bail out of the loop. And that -1 is the century value. It's the value with no meaning for the purposes you're doing, right? If you're adding up test scores or whatever, it's a impossible value. So let's go ahead and do something like that, but we're going to write it two ways. We're going to write it with and without a break statement. Here's how you would do it without a break statement, right? X equals input, let's do the whole thing in one line. X equals float, parentheses, input, parentheses, quote, enter a number, or -1 to exit, in quote, in parentheses, Gotta have 2 closing parentheses because I want 2 opening parentheses. And then I'm going to write my loop so that it says while x not equal 11. So if they type in -1 first thing, we bail. Right? We don't want to even go into the loop. I am tempted at this point to make it one of those loops where you can type in Q to quit, right? Let's do that. I'm sorry for this. It's going to take a couple of edits, but if I take that float parentheses off there, take off one of the closing parentheses and make this say or Q to exit. That's the way people think, right? I want to stop, so I want the option of typing in Q to exit. So here we're going to go. While X, exclamation mark equal, singular double quote doesn't matter, Q, end quote, colon. Then we convert it to a float and do something with it. Whatever we were going to do with it, right? So X equals float parentheses X and print X to the power of 2. Maybe that's why we wanted the numbers, so that we could do X to the power of 2. In which case our prompt should say something a little bit better than just enter a number. It should say enter a number to square. So why not change our prompt up here? Now I have written what is not a good loop. It would be an infinite loop if I saved it. So we're on lecture I. So I run it. Well, I typed in Q first thing, and great. It didn't do anything. That's exactly what I wanted. If I run it again and I give it a good piece of data, I want to find out what 5 squared is. Why is it doing that? Why did it go into an infinite loop? What's wrong with the loop here?
There's no stopping point.
Yeah, X never becomes different. So nothing ever kicks it out of the while loop. We got to ask for the input again. So I'm just going to copy that entire input line and paste it, tab it over one, like that. Now we're good to go. I can type in a number, right? And it's working correctly. It's getting new values of X to play with, and when I finally type in Q, it leaves. So you see that I waited to convert X to a float until after I did the while statement. Because if I had the float here, don't type this, gang. If I typed in float there and ran it, it's going to crash, right? If I enter bad data, if I type in that Q. Right, so if I type in Q right here, it's going to crash. Why? Because a Q is not a number, so it could not convert it to a float. I wanted to make sure that we did not have a Q in our data here before I changed it to a number. And so I separated the input from the float statement so that I could let them either type in a number or the letter Q. We could do even a little bit better. What if they type in, W? They miss the Q by 1. It is going to crash at that point. We're still not quite to the point where we're doing crash-proof programming. Okay, so that is one way. What I dislike about this method is that it has this line of code in here twice. It's got a copy-paste. Pretty much any time you have a copy-paste in your code, you might give it a brief moment's thought to if you can restructure it. And we can. Here's what I'm going to do this time. I'm going to write while, but instead of actually having a condition there, it's just going to say while true. In other words, create an infinite loop. Because how could true become false? So while true with a capital T, unlike a lot of other languages which spell true with a lowercase t, while true, now don't type this part first. I just want you to see. This sets up an infinite loop, so it's going to print an infinite number of question marks. That's not what I want, but it is what I want. But I want it to bail out if they type in an invalid value. So here's what I'm going to do. I'm going to do some copying and pasting from up here. Right? I need that input statement. That's going to be the first thing I put inside the body of the while loop. Then I'm going to check to see if they typed in Q. So if X equals, quote, capital Q, end quote, hit enter, make sure the next line is tabbed over, break. See what's happening here? We get the input, but if they typed in a Q, we kick ourselves out of the loop entirely. We don't even wait until we run a lap, and we're back at the while point. All right, so at this point, we know they have not typed in Q. So indented only one level, make sure you're only one level so that you're under the if statement and not the break. Let's do our conversion and our print. So copy these two lines, x equals float and the print, and paste them here, indented, not indented, indented one level, so it's lined up exactly with the x equals and the if. All right, it's entirely up to you which way you like better. I happen to like this method better because we did not have a copy and paste of the input statement, right? The input statement only appears once in our loop. Logically, they perform, even though the logic is expressed differently, ultimately they perform the exact same task. Now we're reaching the point where it's going to be really annoying to run this program over and over and over because it's wanting input. So we may wind up commenting out the entire thing. Okay, but this is the first loop, right? And I'm going to type in Q to bail out. We probably ought to make the second loop have some slightly different print statements so that we can tell that we're in the second loop, right? And then I can bail out of that one. So they are functionally the same. I'm going to add the word now to this input statement just to distinguish it from the first one so we can tell where we are. Okay, I hope you can see the difference. In fundamentals of programming, we may have called this the priming read. A lot of textbooks call that the priming read. What does that mean? That's like priming the pump, right? Before you can start pumping water out and fill your bucket, you have to prime the pump until, it finally squirts out a squirt of water, and then and then you can get going. This doesn't have a priming read. There's no read above the while loop. The price you pay for not having the input statement expressed twice is that you have an if statement in there. Why do I like it like this? Because there could be multiple statements in here that cause it to exit. What if I wanted to not exit? Excuse me, what if I wanted to exit if they even type in anything that's not a number? I could use something called isDigit. It checks to make sure that this is not a number. And if it's not a number, it breaks. Or what if we just really hate the number -1? Or what if we really hate the number 5? For whatever purposes. I could add a second clause here that would cause us to bail. So unindented from break, right, indented only once. If x equals -1, colon, break. So now there's two ways it could break out. And sure, we could write our while statement here in such a way that it expressed both of them, both of these ideas. We could say while x not equal to q and x not equal to -1, break. But this simplifies this logic, allowing this logic to become a little bit more complex. Now, whether that's a good thing or a bad thing is kind of up to you. If you have break statements hidden in a large block of code, or if you have lots of ways out of the loop separated by a lot of lines of code, it can be really hard to spot how it bails out of the loop. Where here it's real easy, right? There's only one way out of the loop after it's run a lap, gone all the way back around, and is ready to be checked again. This is a very common programming paradigm, and it's usually left out of textbooks. You can use this idea to force them to give you good input. What do I mean by that? Just like I said, what if we wanted to forbid them from typing in something that had letters? We could do that. What if we wanted to forbid them? Yeah, we're going to ask for a whole number, and if they don't enter a whole number, we're going to bail. If they enter a fractional number or if they type in a letter, we're going to bail out. And and rewind that. We're not going to bail out if they've typed in bad data. We're going to loop again, and we're going to keep looping until they give us good data. All right, so I don't have to keep doing all this part. I'm just going to comment all this out. So I'm going to put 3 quotes up at the top, or 3 apostrophes up at the top, and 3 apostrophes down at the bottom. That comments all that code out so that it doesn't do anything now. Oh.
Before you did that, I was running it and I'm not getting into the break when I've been.
Okay, let me come look. Got me there. So what I have done wrong, I've uncommented the code, by the way, for those of y'all watching the video, is that I'm checking to see if it's -1 before I convert it to a float. 2 ways I could fix that. I could put quotes around this, right? Or I could do this if statement after the conversion to float. I like that idea better because it gives you the idea, right? So I'm going to cut those 2 lines, or cut this x equals float. I'm going to cut this x equals float and paste it above if x equals -1. Thank you very much for catching that. Okay, so now that we have a float, we can go ahead and do this math check. We couldn't do this math check until we had already checked it to see if it was cute. That would make this while expression far more difficult to write, right? Because at this point we're checking it against a letter, and at this point we're checking it against a number. And sure, we could make these both, be checking letters with the quotes around it, but just roll with the example. That's a pretty good example of having multiple breaks out of a loop, expressing some logic that's a little bit more complicated than you would actually want to embed in the loop header like that. I believe this is going to work now. Okay, this is the first loop. Type in -1. That's the second loop. So I'm going to come up here and add 3 quotes. And I don't know why I'm switching between apostrophes and double quotes. Some languages are very picky about where you use apostrophes and double quotes. In some languages, if there's more than 1 character between the quotes, you have to use double quotes. It's what it means. And in some languages, when you're comparing a single character, you use single quotes. And I kind of did mimic that. But in this language, they're completely interchangeable. All right. So, forcing good input. This is got a better term than that. That sounds dire, right? Forcing good input. It's called data validation. We're going to use a while true loop to do data validation. We're going to keep looping until they give us good data. What's our definition of good data? In this particular case, it's a whole number. No decimal points, no letters in it. And the easiest way for us to check that is to ask whether the string that they typed it into is digit. Is digit means absolutely nothing else other than numbers. Even decimal points don't count as part of is digit. It'd be nice if there was an is float. We could write our own is float function, but Python does not come with one. What makes is float more complex than is digit? Is float has to allow 1 decimal point, but not 2. And so you have to scan the string, make sure that it's all numbers, and that it only has 1 decimal point and not 2. And that's not impossible. We could write that, but we're not gonna. So here's what we're gonna do. Same business. We're gonna tell them to enter a whole number. While true, capital T, true, colon, S equals input, parentheses, quote, enter a whole number, colon, end quote, in parentheses. Now we're going to see if what they typed in is a digit. So if x dot is digit, no spaces, no underscores, parentheses in parentheses, colon, that means it's good data. It is an integer. It's all digits. There's nothing wrong with it. There are other is commands too. Is space, is alpha, is alnum, standing for is alphanumeric, right? What does alphanumeric means? It means just anything you can type on the keyboard that's either a letter or a number. But if there was any symbols in it, like a asterisk or question mark, it would fail this test. The only way it will pass this is digit test is if the string is all numbers with no symbols and no letters. And if that's true, we can convert it. X equals float parentheses x in parentheses, and then break our loops on the next line, break. If we get to this point right here, lined up equal to the if statement, it means that it failed this test, right? It's basically a kind of a true-false thing, right? We could even stick the word else colon in here because some people like every if to be tracked with an else. Not necessary, but I'm gonna in this particular case because it makes the logic kind of easy to spot. So else colon and then tabbed over, and let's tell them print parentheses quote error dash input must be digits only, end quote, in parentheses. And notice there's no break statement there. So it's going to repeat the loop. It's going to ask them to enter the whole number again. We have done some data validation. Fairly robust data validation. I don't think that there's a way to crash this. In the past, all of our code would have crashed, for the most part, if we typed in something it wasn't expecting. Letters, where it was expecting digits, for example. And so down here, untabbed completely against the margin, we may as well use that data for something, right? I don't know what we're going to do. We're going to print parentheses x star star 3 in parentheses. But that's kind of lame. Why don't we tell them what we are printing? So instead I'm going to make it x parentheses quote x cubed is end quote comma x star star 3. This is a fairly important concept, the idea of looping until you get good input. And eventually you may want to put this kind of code in a function. I think we've already talked about what functions are for. Functions are so that you can line up a whole bunch of code inside a single identifier, so that any time you wanted to execute that entire block of code, you have to use that one word followed by parentheses. Because if I was going to ask for 17 pieces of input, it'd get really tiresome writing this particular while loop 17 times. It'd be better to put it in a function. But we got to get the concept first before we can modularize it. All right, let's make sure it works. I've talked a big game. Enter a whole number, 1.1, or 1 divided by 1, 1.1. Error. Input must be digits only. Enter a whole number. Okay, fine. I'm going to type in a whole number. Whoops, I accidentally typed in a Q. Input must be digits only. Enter a whole number. 1. 1x cubed is equal to 1.0. Now, if I was going to ask for a whole number, then I may as well use x equals int x right here. Right? Because I'm sure at this point it's an integer. Why did I even ask for a whole number if I was just going to turn it to floating point? So I'm going to change that line above the break to x equals int x. Hope that makes sense. The input validation step could be anything it needed to be. Right? You needed to make sure they typed in a whole number. You're double checking to see if it's a password. The rules for the password must be 8 characters long, must have at least 1 punctuation, must have at least 1 capital letter. Then your if check here could be pretty complex in order to check all that, but the logic is the same. Right? If they make a mistake, you print out an error message. If it succeeds all the tests, if it passes all the tests, is it 8 characters long? Yeah. Does it have any punctuation? Yes, exactly, 1 or more. Does it have any uppercase letters? Yeah. Does it have a number? Whatever all your rules are. If it passes all those tests, then it does the break to exit the loop. Could you write this as a while loop? It would be far more complicated to write it as a as a while loop with an expression here rather than just as a while true loop. So if I say while true loop, what I want your brain to immediately click to, okay, I'm going to write an infinite loop that has a secret break out of it. Not that it's that secret, right, but it's right there. As opposed to this kind of while loop where we have a valid Boolean expression up here, and that's the way in and out of the loop. Can you put break statements inside a normal while loop? Yeah, sure, you can. Right, the break can be used anywhere. Can you put break statements inside of for loops? Yeah, sure. Can you put a return there instead of a break if this is a function? Yeah, that's a very common thing to do as well. If I wrote this data validation as a function, then I might put that as a return statement. My preference is to break out of the loop and then have return underneath the entire block of code. It's generally good at programming if you can manage to only have one return statement out of a function and it just appears at the bottom of the function. It's just easier for your eyeball to take in quickly what it's doing. So a while loop is also called an entry control loop. Yeah, sure, sounds good to me. Nobody else uses that term. While condition, do the statement. If it's false, wait, no, that's an if loop, is it not? No, I see the arrow going back up now. These beige colors are kind of hard to see. But anyways, if the condition is false, it skips everything, right? While x equals 0, if they type in non-zero, then it skips everything. But if x really was equal to 0, it does the body of code and it repeats it. Now I happen to draw this flowchart fairly differently. I make the false fall straight down and the true tabbed over. Why do I do that? Because if you tab the true over, it looks like your code, where the true block is tabbed over. Whatever. Had a disagreement with another professor. Said that this was the modern way of doing it. Right? Well, I don't care if it's a modern way. It's a little bit more confusing to read if the code that gets executed is not indented, if it's not to the side. Anyways, here we go. The variable that you're testing is called the loop control variable. In this particular case, we've been using x throughout, right? So x is our loop control variable. X is what has to be changed before the while loop will exit, or x is what has to equal a certain value, a certain century value before we break. I'm going to go back up here and add the comment that -1 is the century value. So where it says x equal -1, just to remind ourselves of what a century value is. Really need to remember to upload this new one. Their habit of not tabbing things over in the example is a real pain. What do I mean by that? Here, this number is counting from 1 to 10,100,001. If I put print the sum inside here, it'll print the sum out 100,000 times, and the code's going to be kind of slow. Or it's going to just put out a whole lot of input. Let's see if I can actually paste that. Sometimes you can't paste from PowerPoints and actually have it work. Right. Yeah, takes a long time to do that. Or was it 1 million? Was it 10 million? It seems to be repeating a lot longer than I was expecting. 1, 2, 3. Should not have it stopped at 100,001?
It's going to print 100.
But it's going to print it out
101,000
101,000 times. Now, I honestly don't know why. Well, check it out. It's not doing it by ones. And did you spot the problem already? I didn't spot it. It's going up by 14, 15, 16, 17 times. Oh, that's because it's printing the sum, not, okay. So if I did, here I'm going to actually show what it's doing. X comma, and you probably had spotted. Here we go. Now I can actually see the value of x. No, I can't. What was my counter called? Count. Fine. Alrighty. They're better programmers than I am. They use avoid one-letter variable names. All right. Okay. Now you can see this. It's not going to exit until this first number is 100,000. You can see that that takes forever. It's valid code, but I don't want to wait. Right? Computers run very fast. What are they slow at? Updating the screen. If your Fallout game or whatever did not have to display anything on the screen, it would run, you know, almost infinitely fast. Right? It's a video card and how fast your memory is and how many, you know, what kind of chip in it that determines, right, you know, the size of the screen, whether, you know, you've stretched it out to be a 4K monitor or what. All of that is what slows your machine down. It's all that visual stuff. So in this case, what is slowing it down is the fact that I'm printing every single number. If I back tab this, it is no longer part of the loop. Boom, you saw how fast it was. It repeated this 100,000 times, you know, in the span of a, you know, tenth or hundredth of a second, and only printed out once. So these tabs are real important. So it's a real shame that the textbook does not show where the tabs are. I had to just guess that this is how I wanted it tabbed, just by my experience, right? Because we don't want to print it every single time. Same business down here. We don't want to print it every single time. By the way, this code is doing the exact same thing. Here they're using a definite loop, a ranged for loop that counts from 1 to 100,000. I know that it's going to stop when it hits that 100,001, so it's actually going to count 1 to 100,000. Down here, we're doing the same thing with a while loop. There's pretty much nothing that you can do with a for loop that you can't do with a while loop. And that's definitely not true in this language. The reverse is definitely not true in this language. Lots of things for a while loop that you just flat out cannot repeat with a for loop. The while loop can be complicated to write correctly. It's possible to simplify its structure and improve its readability. Okay, again, we're going to have to tab things over. While true, there we go. What is their century value this time? Just hitting enter. That's their century value. I kind of like that one, but you can accidentally hit enter, right? So anyways, this bails it out, and this is exactly what I was showing you. Our century value, our value that let us bail, we let them type in Q, right? That was one way to get out. Same thing. We're saying that this is simple. That this is simplified its structure and improved its readability. I don't know that's that much simpler, but it is somewhat. The only thing that I see that's an advantage is that this input statement is only done once rather than twice, as it was in my very first example. Now this is looking a lot more complicated than it did up here because I added this second if x equals -1. If I want these two blocks of code to do the exact same thing, I'd better delete those two lines. You don't gotta, right? You've already typed the code. But now the logic is exactly the same. It's your personal preference as to which one you think has improved readability. Maybe this one does, right? It doesn't have an if statement in it. This example modifies the input of the grade conversion program to continue taking input numbers until they enter an acceptable value. Here, this is our data validation. While true, do this. If the number is greater than 0 and number is less than 100, what is this saying? This is saying that it's a valid number between 0 and 100 because those are good test scores. And if it's a good test score, bail out of the loop of the break, else give them an error message. Print. Grade must be between 100 and 0. In this particular case, we could leave off the else statement and it would perform identically. Why? Because if it didn't break, that is going to get done automatically, just like the purpose of an else. If you like writing else, like I demoed up here, that's totally cool. But you see that it looks like I eventually deleted my else right there. Oh, but I left it here. I could have removed it here, right? Exact same code. Because if this is not true, it has to repeat that. I mean, it has to execute that, just like if there was an else in front of it. It's up to you whether you think that that's easier to read with the else keyword or whether it kind of clutters it up. It adds one to the length, and then we have 2 blocks of code that are tabbed. Up to you. Or use a Boolean variable to control a loop. This is also common in practice. If they type in a number between 0 and 100,000 inclusive, then we set the done variable to true, and it can exit the loop. So our while header says while not done. Instead of saying while true, it's basing its expression on a Boolean variable. Like I said, most textbooks don't even show while true. So if they were going to do it, then this is a perfectly valid way of doing it. Why would I tend to not do it? I'd rather see the break statement. The break statement makes me immediately understand that it's bailing out here. If I'm in 100,000 lines of code, okay, that's a bit excessive. If I'm in 50 lines of code or 70 lines of code and I see something equals true buried in the middle of it, my eyes may not even see that as I'm scrolling up and down, but my eyes are trained to find break statements. And so I would immediately know that that's going to cause it to break if that had been done with a break rather than with a Boolean variable to control the loop. Again, that's our loop control variable. So programming languages include resources for generating random numbers. Why? Because random numbers are cool. You're writing a game. You don't want the game to behave the exact same way every time, unless you do, right? So in the original Pac-Man game, the ghosts followed a very specific algorithm for tracking you down. So it's possible to have a pattern for each maze that if you execute it perfectly, the ghosts move the same way, the same time, and you can avoid them. And so it used to be a big deal, and I suppose it still is to the 7 people who care about these things, to come up with patterns that would force the ghosts to come the same way because there was no random behavior. However, Ms. Pac-Man was written to be more difficult so that people would not sit there and play the same game on 1/4 for an hour and a half. And so some of the ghosts moved randomly. So as they were moving around, you would never be able to predict which way it was going to turn next, right? It'd also be pretty boring if every time you rolled dice, you were going to roll up a D&D character, or you were going to play Yahtzee or Monopoly or something, if they rolled the numbers in a very predictable fashion, in a non-random fashion, right? You like your dice to be supposedly random. So random numbers make code a little bit more fun. I could write a program, and we probably will, that says if, guess a number between 1 and 100. The computer picks a random number, so I don't know what it is asked. And so I would guess 50. And it would tell me, no, that's too high. And so I would pick, 25, something like that, in order to get it to go. We did random numbers once, didn't we?
Yeah.
This is not brand new. Okay, so to get the random number thing going, you have to import the random the random library, and then you can call random.nextInt if an integer is actually what you want. So if we were going to write a program that would keep printing out random numbers until we rolled doubles, we can do that. May as well put something like that into our code just to remind ourselves. So while true, but we need our import random above that because we don't want to keep importing a library inside a while loop. Importing something takes a little bit of time. So above that while true, what? Okay, that's what I was trying to do. While above that, import random. While true, let's get our 2 random numbers. R1 for roll 1 equals random with an N, random dot next int, and I want my number between 1 and 20. In Dungeons and Dragons or Pathfinder, you have 20-sided dice, technically called an icosahedron, right, for some things. And we're going to roll until our dice are equal to each other. The odds of that happening are less than if you just rolled 6-sided dice and found out that they were equal. And I can't calculate statistically what the odds are, but a statistics or a math guy could. I shouldn't say guy, right? When I say guy, I'm using it, in an inclusive fashion. Women are guys too. So R2 is equal to random dot next random dot. I goofed. It's random dot next int. You're gonna have to fix both of those lines. Fix this first line so it says random dot next int. Change the second line so it says random dot next int. And again, that's wrong. I'm totally botching it. I'm sorry. I stepped out of Java where this index is a little bit different. It's RANDINT.
Yeah.
So come back up here and change this to say random dot RANDINT 1 and 20. And the next one should say random dot RANDINT parentheses 1 comma 20. Now we need to check to see if they're the same. If they are the same, we're going to break. So if R1 equals R2 colon, hit enter, so it's tabbed over, break. Now if that didn't happen, let's print a message. It'd be more fun to count how many times. We should put a counter in here saying how many times.
Yeah, how would that just be simple as something like count equals
Count plus 1, right. So if we let's finish this one and then I'll add the counter to it. Okay. So if that didn't happen, no, because I want the counter to already be here by my print statement, so I don't have to revise my print statement. So I'm going to come up here below import random, totally untabbed against the margin. Count equals 1. Right. Our first roll counts as 1. We could set it equal to 0, and we could increment it right here inside our while loop. Probably be better. Logically, it's the exact same thing. Okay, so if they were the same, you know what? We should print out our numbers before our if statement, because if we break and our print statement is underneath here, under the if statement, then we won't see the results when they equal. So above that if statement, I'm going to say total equals R1 plus R2 . And then this print statement is going to be pretty cryptic. I'm not going to make it nice where it says roll number 1, you rolled a 7 and an 8, right? Something like that. Instead, I'm just going to print, and inside the parentheses, I'm going to put count, comma, R1, comma, R2. Oh, I guess if I calculated the total, I should do it with something. So count, comma, R1, comma, R2, comma, total. And really, I should use those placeholders in a formatted print statement to, print something good. Okay. I believe this will work unless I have syntax errors. Let's find out. And I forgot to increment the counter. So it always printed out 1. So I'm going to do else colon here, but I don't actually have to have the else. I've told you that, so I'm going to remove that word else, and I'm just going to make it say count. You could type in count equals count plus 1. I would rather say count plus equals 1. No spaces between the plus and the equal. And our whole number, alrighty, getting tired of that, may comment it out. Okay, this time it took 21 die rolls. Rolling those dice 21 times to get a match. Wow, in some games that'd be a pretty awesome hit. You roll a natural 20, it's a critical hit, and then you roll again to see what, anyways. Alright, do that again. It only took 7 rolls to get it to match. And weird, it matched again on 2020. That's pretty interesting. Why is it always matching on the same die roll? Surely not 3 times in a row.
Why Mine's different originally.
Yeah, okay, here, when I rolled 9 and 9, it bailed out, but it took 38 die rolls. It's effectively random.
I got 19.
Yeah, it's not 100% truly random. It's called pseudo-random. Pseudo-random means that it follows an algorithm. It'll pick the first value based on something like the number of seconds since midnight, or you know, the number of milliseconds that we're inside in the second, something like that. And then all the numbers are calculated algorithmically so that the next number is determinate upon the last number calculated. We can't predict that series, so it's random to us. But if you manage to run the same program on two computers at the same exact millisecond and it had the same formula, then you would get the same sequence of numbers.
Is it just set seed? Is that how you do it?
Right. If you want to generate the random numbers so that they don't look random, you can in fact set the seed, the first value, the seed that it is using to generate these random numbers. And is it just random.setSeed? Have you already Googled that up?
I'm not too sure because I know
Let's go look.
It says set seed.
Yeah, let's go look.
You have to have those repeatable results.
Not set seed. There we go.
Okay, so
Oh, dot seed. Okay. If I wanted it to generate the same sequence every time, which for testing purposes you might want, right? It seems to crash sometimes, but not always. I need to find out what sequence of values is causing it to crash. So as soon as I import the random, I might want to set the seed, which is the first number in the series. We don't get to see the seed because the first random number is generated on it, but that's the idea. So random.seed, parentheses, and it could be anything. Any valid number will work. Now it's going to generate the same number every single time. Or, I mean, not every, it's going to generate the same sequence of numbers every single time. So it took 30 times and I rolled double threes to quit. If I run it again, do the exact same thing, right? So if you don't really want random numbers, if you just want them to, you know, kind of look random, but you want the same sequence every time, you would set the seed. I think I'm going to comment that out because at this point I kind of like the numbers looking random. But here we go. So let's do the kind of game where we have to guess a number in order to exit. Pick a number between 1 and 10. The computer has to have a guess. It has to store a guess. It has to calculate a guess. And then the human is going to start guessing against that. So I'm just going to call it secret. That's the secret number. Is equal to random dot RENDINT 1, 10. I'm making the range small so it's easy for us to guess, right? If it was between 1 and 100,000, we'd sit here typing in guesses for a long time. Let's use a while true loop to get us out of it. While true colon. Ask them to enter the number. I'm not going to do any fancy data validation. So I'm just going to do it the original style that we were doing up to this point. Let's call this guess, though, rather than just X. Guess equals float, parentheses, input, parentheses, quote, guess the number, end quote, in parentheses, in parentheses. Now they don't know why they're guessing, so we should put a print statement up above the whiles to tell them what they're doing. Right. So above the while statement, let's tell them the game. Print. Let's play a game, period. I'm thinking of a number between 1 and 10. end quote, in parentheses. And it goes off the screen, but you know what's at the end. Double quote and end parentheses. Maybe I can nudge it over just a little bit more so that we can see the whole thing. Not really. Seems like that's even less. Why would it be if I zoom in? Oh well, whatever. Fine. All right. Just accept it. End double quote, close parentheses. So we've told them what we're doing. So we've gotten our guess. Now let's check to see if they got the right number. So if guess is equal to secret, if guess equals secret, congrats, they got it. Print, parentheses, quote, congrats, you guessed it, end quote, in parentheses. Else, let's tell them they didn't, but we better break if they guessed it correctly. So tab equal to the print statement, break. Now back tab to 1 so that it's lined up with the if, not against the margin though. I am going to use else. I think it kind of maybe makes it look easier to read. Else colon, print, parentheses, quote, sorry, not correct, period, guess again, exclamation mark, end quote, in parentheses. And I haven't been doing this for most of my code, but if you have a long while loop, it's not a bad idea to put a little comment down here at the bottom that says end while, right? Because if you're 2, 3, 4 pages down in your code and you can't remember if you're inside a for loop or an if statement or a while or a function, it's not a bad idea for your final back tabbing to have an indication of what it is. Now this isn't a perfect game in my opinion. I'll ask y'all for the suggestions for improvements, but it's probably actually going to be the homework is for you to take this guessing game and improve it. So enter all number 9. I'm getting real tired of that. All right, and then get rolled random numbers, and I'm thinking of a number between 1 and 10. Can we get it to show the bottom input, please? I know I'm zoomed in. All right, here we go. Guess the number. 9. Sorry. 10. Sorry, I have to kind of brute force it because I have no idea. What's brute force mean? I'm just going to start guessing. 8, 7, 6. Right. Okay. I'll bring the code back. Let people finish typing in. But you saw the way it ran. What could improve? All right, gang, for those of y'all who are gone, and what I mean by that is I forgot to resume the counter. Resume the camera. Our current guessing game looks like this. Let me just show you how it runs first, and then we can look at the code real fast. Enter a whole number, yeah, whatever. Guess the number 10, right? Sorry, not correct. Guess the number again. 9, 8, 7, 6. Oh, come on. 5, 4. Really? 3. All right, and it took 8 guesses. That's the current state of our code. And it's written like this. You can pause the video and explore that really carefully. All right. Anybody have typos that you want me to come look at? Y'all are definitely too good. Now, let's come look. Awesome. Oh. Ta-da. Well, this just blows my guessing game out of the water, the homework, because it's showing you how to do too small or too large. Lame.
It's there, I thought of it.
Right there.
There you go. Just delete it now or post a PowerPoint.
Well, everybody's going to have the ability to go and look at their own PowerPoint. Well, I'm going to make it part of it anyways. All right. You'll have to integrate that code there into your own. Errors to rule out during testing while loop. You can have problems with your while loops. What if I didn't initialize my loop control variable? What do I mean by that? Up here I have a counter, right? And it's counting how many times it rolled the doubles, right? It had to roll. So it may have taken 20 rolls to get my doubles. And then I came down here, and what if I'd forgot to reset my counter? Then my guesses are going to start at 20, right? And so I get it right in 3 times, and down here it's going to tell me it took you 23 guesses, and you're going to be annoyed. You didn't get credit for doing it in 3. Or what if you only had 10 guesses, but the counter started off at 20? Then it might not even let you, play the game at all. It might, how would you check to see what the counter was? Instead of while true, you might say while count less than 20 or something like that. And if it had rolled 100 times here, then count would not be less than 20. It wouldn't even let us play the game once. So I'm definitely not going to make that change. That's a common mistake, not initializing your loop counter. Usually it's just a syntax error, though, right? Because usually it won't even run. But in that case, I already had used the count variable. Failure to update the variable. Right? If you're having something that says while x is less than 20, but you never change the value of x, it's never going to leave. It's going to be an infinite loop. And the failure to test it correctly in the continuation condition. If you just write your while statement wrong, while x is less than 20, but really you want it to be less than or equal to 20, then it's not going to behave correctly. Or what if you accidentally type greater than, while x greater than 20? And your logic should have said while x less than 20. It's not going to work correctly. If it's an infinite loop, you can either do Control-C. That's a classic thing going all the way back to the 60s or something like that as a way to interrupt it. I'm not sure why C, though. Anyways, because nowadays it means copy. But anyways, if I make one of these an infinite loop by forgetting to get second input, then if I need to, I can bail out with Control-C. But how would we probably bail out? Probably just with by closing a window. But let's tell them. But now let's just do this. While true, colon, x equals input parentheses quote. Now let's not even do that. Let's just do a print statement. Print parentheses quote, hit Control-C, end quote, in parentheses. That's about the shortest infinite loop I can come up with, right? A while statement that whose condition never becomes false, and then it displays some kind of output so that you know it's an infinite loop. It's worse writing an infinite loop if there's no output inside it, right? Because then you can't see that it's infinite loop. You just know that it's infinitely looping because the program never finishes. All right, gotta play my game. 1, 2, 3, 4, 5, 6, 7, 8, 9. All right, it's infinitely looping. Now, what would you normally do? You'd probably just click the close box. But if you want, you can hit the secret key Control-C. Probably, maybe Command-C on the Mac. I don't remember. Try Control-C first. And here's what it says. Keyboard interrupt. We killed our program with a keyboard interrupt. Control-C is a keyboard interrupt. We stopped its running. If you're ever using a window that's running in a terminal, in a console window like that, Control-C will probably bail out. Of course, if you're using Word or Excel. Now, why would I want to Control-C rather than just close the window? Because if I close the window, I won't be able to scroll up and see what the program was doing at the very beginning. Right? If I just close the window, I can't scroll up and find out what set this up. That's why you care about Control-C. All right, we've got like 4 pages left. Let's see if we can get them all 3. So if your loop's running infinitely, type Control-C to stop it. If the loop must run at least once, use a while true loop with a delayed examination of the termination condition. What does that mean? You do your check before you have the break, right? If I write this while guess equals secret, then if I've set up my variables wrong, it won't even go into the while loop. If I absolutely want to make sure that something happens inside the while loop, then I put my break condition inside, a couple lines down, not as the first thing. Do ensure that a break statement can be reached, or else it's going to be an infinite loop. So control statements determine the order in which other statements are executed, like a loop, cause things to happen over and over. That's controlling the order. If statements, pick either one block of code, whether it's going to execute those or not, that's the order. A while, dictating the order. Definite iteration is a process of executing statements with fixed predictable number of times or with a fixed series of values. Using a range statement, you'd use a for loop. Your for loop consists of a header and a set of statements called a body. The body is all tabbed inside it, just like a while loop, right? You have a while statement, the body of the code is tabbed. So if you use %, you can format your output. Like if you wanted to always print, up to 2 decimal places, you put %.2f to display 2 values after the decimal point. An off by 1 error occurs when the loop does not perform intended number of iterations. Like if you do range 1, 20, and you're expecting it to go all the way up to and including 20, that's an off by 1. Ultimately, a Boolean expression evaluates the true or false, just like up here in our code. As long as that's false, it'll keep repeating the loop. No, as long as this is true, it'll keep repeating the loop. If this expression ever becomes false, it stops. Just like an if statement, if this was false, it wouldn't do anything inside the body. Selection statements enable programs to make choices. Right? If x equals 1, print this. If greater than or equal to 90, print A. We talked about short circuit evaluation, if you remember. If you have an AND, but the first condition is false, it doesn't check the second condition. If you're using an OR, then if the first condition is true, it doesn't bother checking the second one. That's to speed it up. You already know that AND means both sides have to be true. OR means either one or the other, and not just reverses the truthiness. So if you do not true, it becomes false. If else, we know what if else is. We don't talk about if elif here, but let's just say that we know what if elif does. I guess they're saving that for a later chapter. A while loop is an entry control loop, meaning that it's checked up at the top. Break will exit. They're skipping a keyword called continue, which is also useful. I hope I remember to mention that. I'll make a note for myself. Any for loop can be converted to an equivalent while loop. That is true, but the reverse is not true. An infinite loop, we know what an infinite loop is. Random.randint returns a random number. All right, we are done with the chapter. What's our homework going to be? It's just going to be to modify our game. And by the way, I will write this up. And sometimes when people do the homework, they leave everything else that was in the notes, right? We don't need a dice game where we're trying to roll equal signs. And we don't need something up here that asks us to enter a number and checks, right? All we need in our result is the guessing game. The homework doesn't need to be the entire notes modified. Now usually I don't, count off for that, but it can be really annoying to test if there were 20 input statements in the test code. So, our homework. Modify the game code, which will be included in the homework assignment. 1. Let the user know whether the guess was too low or too high. 2, let the user specify the upper bound. Like if they want to say 1 to 100, then they would type in 100. But if they want the numbers to be between 1 to 10, they'd guess in 10. And 3, limit the game to allow 10 guesses. And 4 is extra credit. Print hot if the guess is within 10 of the result. That's kind of vague. Because if you're guessing only between 1 and 5, then it would always be hot. But let's just roll with it, right? Else print cool. If you want to make it even more awesome than that, see if you can figure out how. But that's the extra credit step. Alright, we got to make our Dropbox so that y'all can get out. Let me do that, then I'll bring this back up because I know lots of people like to actually type the homework into the notes.